Welcome to the DIY Honda Garage channel. The DTC P0095-17 pertains to an issue identified in the Honda CR-V 2023 model concerning the intake air temperature IAT sensor 2. This diagnostic trouble code indicates that the output voltage from IAT sensor 2 has exceeded a predetermined threshold, resulting in the powertrain control module (PCM) detecting an abnormal condition. The IAT sensor 2 plays a vital role in monitoring the temperature of the air entering the engine. This information is crucial for determining the right fuel mixture and optimizing engine performance. Located near the intake manifold, the sensor works in conjunction with the PCM to ensure the engine operates efficiently. If the output voltage from this sensor is too high, ignition timing and fuel injection may be negatively affected, potentially leading to diminished vehicle performance and increased emissions. The troubleshooting process will require a thorough inspection of the sensor, as well as the related electronic components and wiring harnesses. The IAT sensor 2 is fundamental in gauging the temperature of the incoming air, which is essential for the PCM to adjust the air-fuel mixture appropriately. It is typically situated near the intake manifold, making it well-positioned to measure the air's temperature before it enters the combustion chamber. A high-voltage reading from the IAT sensor 2 indicates that it's either malfunctioning or that there are issues in the electrical circuits connecting it to the PCM. The PCM uses input from the IAT sensor to optimize the combustion process, indirectly influencing fuel economy and engine performance. If the sensor's voltage exceeds 4.92 volts during diagnostics, it triggers this trouble code. It's important to accurately address this issue to ensure that the engine operates efficiently and remains within emission standards. Several factors could lead to the triggering of DTC P0095-17. First, a faulty IAT sensor 2 is the most common cause. If it's not accurately reading the air temperature, it will produce high voltage outputs. Furthermore, damage or failures in the wiring associated with the sensor can cause voltage readings to spike. This includes issues like short circuits or open wires that have increased resistance, leading to misreported sensor values. Another potential cause could be a malfunction within the PCM itself. While this is less common, if other components are functioning correctly, the PCM may need to be examined. Performing precise diagnostics is essential to narrow down the source of the issue effectively. The symptoms associated with DTC P0095-17 can substantially impact driving experience and vehicle performance. The most immediate sign is often the illumination of the check engine light, which alerts the driver to potential issues. Due to the faulty air temperature readings, the engine might exhibit poor performance characteristics, such as sluggish acceleration or rough idling. Additionally, the PCM's incorrect adjustments based on erroneous sensor information can lead to increased emissions, a crucial factor in meeting environmental regulations. Another noticeable effect could be reduced fuel efficiency, resulting from improper air-fuel mixture calculations. Addressing this DTC promptly is imperative for maintaining vehicle reliability and efficiency. The first step in troubleshooting DTC P0095-17 involves directly inspecting the IAT sensor 2. To begin, the sensor connector must be disconnected, allowing for a clarity in testing without interference. Using Honda Diagnostic System, HDS, the voltage at the IAT sensor should be analyzed. If HDS indicates that the intake air sensor voltage is above 4.92 volts in the on mode, the trouble can be confirmed as duplicated. Maintaining a careful approach is essential during this inspection so that accurate readings are obtained. If the sensor voltage remains outside the normal range, further investigation into the IAT sensor itself may be warranted to determine the source of the high voltage readings. Moving forward with these initial checks sets the stage for more comprehensive diagnostics to isolate the problem. For the second troubleshooting step, the focus shifts to inspecting the external circuit connected to the IAT sensor 2. Both the ITA2 or INTA and SG2 wires require careful examination. Before disconnecting the PCM connector, it is crucial to jump the SCS line with HDS and allow for a wait time of over 1 minute to reset any stored issues. Once prepared, with the IAT sensor 2 connector and the PCM connector both disconnected, a systematic inspection for continuity in the wires can be performed. Normal conditions stipulate that results should show less than 1 ohm of resistance for both ITA2 and SG2 open wire inspections. If any abnormalities are detected, this suggests a problem in the wiring or connections, warranting further investigation or repairs to those circuits before moving forward with other components. Once both the IAT sensor and the associated wiring have been assessed, the final step in troubleshooting DTC P0095-17 is to inspect the powertrain control module, PCM. This step is crucial for confirming the root cause of the detected issue. If all previous tests have returned normal results, yet the DTC persists, the remaining suspect is often the PCM itself. A malfunctioning PCM may not properly interpret signals from the IAT sensor or respond with appropriate adjustments to engine functions. This procedure requires specialized tools to evaluate the PCM's inputs and outputs and ensure it operates within specified parameters. Replacing or reprogramming the PCM can be necessary if a fault is identified during this inspection. Understanding how the PCM's functionality affects overall vehicle performance is key to successful diagnostics. Following the successful completion of all previous troubleshooting steps, the final repair verification process for DTC P0095-17 focuses on ensuring that the vehicle operates as intended. This involves conducting a test drive to evaluate whether any symptoms related to engine performance or functionality arise following the repairs. During this drive, the technician should closely monitor the vehicle's response, specifically watching for the check engine light returning. Once comfortable that the vehicle performs correctly, a final check using HDS can help confirm no DTCs reappear, signaling successful repair efforts. This thorough process not only ensures the immediate issue is addressed, but also confirms the vehicle's overall health and reliability moving forward. Preventive maintenance is an essential practice to avoid the future emergence of DTC P0095-17 and other similar issues related to the IAT sensor 2. Regular checks of the IAT sensor can ensure that it continues to function optimally, allowing for timely identification of potential irregularities. Additionally, inspecting the wiring harness, including the integrity of the connections, can mitigate risks related to misreading due to faulty wiring. It's also beneficial to conduct performance diagnostics routinely, which not only helps in revealing issues early, but also aids in maintaining engine efficiency. Keeping up with regular vehicle maintenance, including clean air filter replacements and engine tune-ups, further supports the longevity and efficient operation of components within the air intake system. In summary, DTC P0095-17 serves as an important diagnostic signal regarding potential issues with the intake air temperature sensor 2, directly influencing engine performance and emissions. Understanding the role of the IAT sensor is critical, given its impact on the air-fuel mixture that the PCM relies on for optimal engine function. Accurate readings from this sensor are vital, as any discrepancies can lead to significant performance setbacks and compliance issues. Venturing through effective troubleshooting steps involving inspections of the sensor, wiring, and PCM is crucial to resolving the issue. Through preventive maintenance, vehicle owners can also ensure continued operational integrity, thereby mitigating future issues linked to the IAT sensor too. Keeping these points at the forefront can help maintain the performance and reliability of the Honda CR-V. Please like and subscribe to the channel. See you next time!